Please turn to the first page of Chapter 12 in your textbook. The chapter is on meats, poultry, and fish. For the purposes of this presentation, I'm just going to be looking at beef. The nutritional composition of beef, you can see here that the composition is mostly water, 75% water. And it's this high percentage of water in the muscle tissue that helps to explain the challenge of shrinkage of the meat during cooking. Excessive moisture loss during cooking will lead to dry meat, a loss of product weight, and ultimately then a loss of the product profit. When looking at the protein content of the muscle tissue, you can see that it's about 20% protein. Beef is a source of complete protein, so one that contains all of the essential amino acids. As the meat is cooked, the protein content in the muscle tissue becomes firmer and loses moisture as it coagulates. Doneness is related to the desired degree of muscle protein coagulation. Excessive coagulation results in the toughening of the proteins and an increased moisture loss. The level of fat is quite variable, between 4 and 10%. The fat can be deposited throughout the muscle tissue, so that is called your marbling. It can also be found outside of the muscle tissue, so that surface fat that helps to retain the moisture during the cooking. A certain amount of fat is desirable for the perception of juiciness, tenderness, and the flavor of the meat product. Carbohydrate, very, very little, less than 1% of animal protein is carbohydrate. There is just enough carbohydrate present for the Maillard reaction to occur, resulting in the browning of meats that helps to promote the flavor of the meat. When looking at vitamins and minerals within beef, beef is a good source of the B vitamins thiamine, riboflavin, and niacin. And it's a good source of the minerals iron, zinc, selenium, and phosphorus. When looking at the meat composition and structure, there are five features that we need to spend some time on. First of all is the muscle tissue. And the muscle is made up of 3 different proteins as they're listed there. The myosin, actin, and tropomyosin. And when the actin and the myosin join together during muscle contraction and relaxation, the actomyosin is formed. The second component of the structure of meat is the connective tissue. And the connective tissue is what holds the muscle cells together. So we have 4 different types of connective tissue. First, we have collagen, which is a white, soluble, fibrous substance that's found within and between the muscles. Collagen, when heated, is converted to gelatin. And that's what the image of the slide is the formation of gelatin when the meat is chilled. So I don't know if you've ever made a beef roast or something like that and you put it in the refrigerator overnight and the liquid has solidified and it's a little jiggly, just like Jell-O would be. So that is the visual of where the collagen connective tissue has been converted into the gelatin. The second type of connective tissue is the elastin. It is found intramuscularly and is resistant to chemical changing. It doesn't change. The elastin stays tough and fibrous even after the product has been cooked. It is more yellow in color. The third one is the reticulin, and it is the connective tissue found in fatty tissue Little change is seen here. It's really a minor player in terms of connective tissue. And then lastly, we have the ground substance, which holds together the collagen and the elastin, and it changes somewhat as the protein coagulates. The biggest feature within the connective tissue, or the most important type of connective tissue, is the collagen, and the fact that it is soluble and it is converted to gelatin as the protein coagulates. A little closer look here now at the organization of the meat fibers. This visual is not in your textbook. Your textbook has a different visual. So let's just start at the top here, and we're looking at skeletal muscle. And within that image, this paramecium is the outermost layer of the connective tissue. That's what holds all of the muscle bundles together. Now, one of those muscle bundles is the second picture there, the middle picture. And if you pull out that middle picture and look at each individual muscle fiber, that's in the bottom picture there. So the endomecium consists of the ground substance and collagen. So it's the connective tissue between the muscle fibers. The paramecium holds the several muscle fibers together. And then finally, that epimecium is what holds the muscle bundles together. Looking on then into the fatty tissue, two different kinds of fatty tissue. We have the intramuscular fat, which is also called marbling. That is what we see as the flecks of fat found throughout the lean muscle tissue. Most often, the more marbling a cut of meat has, the more tender the cut of meat will be. The intermuscular fat is the fat found between the individual muscles. So that is the muscle that surrounds the cut of meat, if you want to look at it that way. The presence of fat, whether it's intramuscular or intermuscular, contributes to the perception of juiciness and flavor of the meat. Fourth structure component there are the bones. Bones may or may not be found in the cuts of meats that you purchase, but the bones can be used to determine the cut of the meat. Real interesting there. And then finally, we have the color pigments. The color of meat comes mainly from the pigments hemoglobin and myoglobin. Different meats have different amounts of myoglobin, thus affecting the color. For example, pork is going to be less red in color because it contains less myoglobin than beef. It's the difference between the difference in the color between dark chicken meat and white chicken meat is also due to the amount of myoglobin. There's more myoglobin in the dark meat than there is in the white meat. A third color pigment there, astaxanthin, is the pinkish carotenoid pigment in salmon. There are numerous interactions and changes due to the color pigmentation based on exposure to oxygen, air, heat, light, different sources of light. So we're going to start here. The changes in the color pigments mostly is due to the heme iron that is found within the hemoglobin and the myoglobin. So hemoglobin is the largest color pigment. So there's more hemoglobin in the meat. However, the myoglobin has the most effect on the color. So even though it is secondary, myoglobin is secondary in the amount of that color pigment, it has more impact on the color pigmentation than the hemoglobin. So it is the myoglobin that leads to the purplish red color when the meat is fresh and protected to air. That's the top of your slide there. The iron is in the ferrous state at that point in time, so the 2+ state. When the meat is exposed to oxygen, the myoglobin adds 2 oxygen atoms, which creates the intense red color that consumers equate with fresh meat. So that's looking down the left-hand side of your slide there. So when we add the oxygen, it becomes the oxymyoglobin. So that beautiful red piece of meat there in the bottom left-hand corner of your screen. With further oxidation, the metmyoglobin is formed. That is the brownish red color that forms when oxygen is reduced or the meat is exposed to light. Okay. In that one, we've changed the iron state from the ferrous state to the ferric state. So it's that change in the iron status that leads to that real ugly brown color that we equate with spoiled meat or rotten meat that we don't want to consume. The effect of light on color pigmentation is pretty remarkable. So when meat is exposed to fluorescent or incandescent light for too long, we see that brownish metmyoglobin forming. So this illustrates the color changes from 1 to 7 days with the exposure of the ground beef to the fluorescent lights or the LED lights. So this has implication for the butcher and for the meat in the case at the supermarket. The exposure to light will affect the color pigmentation. The effect that heat has on color pigments, we will see the myoglobin being converted to the oxymyoglobin, and then the oxymyoglobin with more exposure to the heat will form that denatured globulin hemochrome. So you can see there for the picture on the bottom, we go from the myoglobin that we really don't see because it's not that purplish color. So we're starting off there with that rare steak being the oxymyoglobin, and then with more heat, the color changes more to that brownish color. If you look over there to the well done steak, we're going to have this higher proportion of the globulin hemochrome. Now, color pigments are also affected by the curing of meat. So meats such as ham and bacon are cured, and to cure, we usually use sodium nitrate and salt to preserve the meat. Curing is just the preservation of meat using sodium. In the curing process, nitric oxide, which forms from the nitrates in the meat curing, combines with myoglobin to form nitric acid myoglobin. Okay, you can see that there on the left-hand side, second slide down. Gives us that real dark meat. We're still in the ferrous iron state. The nitrohemochrome or the nitrohemoglobin or nitric acid hemoglobin is the key color pigment in cured meats. That's down in the lower left-hand corner. This is a denatured globulin when the cured meat is heated. Okay, so that's the color that we associate most with ham. With continued oxidation and exposure to light and air, that will lead over to the bottom right-hand corner to the denatured nitrohemochrome or the denatured metmyoglobin. So we have what the cooked ham might look like if it's overcooked, Okay, so we've got that grayish brown iron in the 3+ ferric state. So an excellent visual here of ham and the different colors of ham based on the different steps, different phases of the myoglobin. Moving on now to the processing of meat. So meat inspection is mandatory. It's covered under the Wholesome Meat Act, which requires state government to have local programs of meat inspection equal to those at the federal government level for meat sold within the state boundaries. The United States Department of Agriculture has the responsibility at the federal level for inspection, grading, setting of standards, and labeling of meat products and poultry products. Inspection checks for the wholesomeness of the meat, and if the product passes, then we will see the round inspection stamp somewhere on the carcass. It does not have to be on each individual cut. This rolled inspection stamp must be somewhere on the carcass. So the inspections process main goal is to protect the public from animal disease. Meat grading is not mandatory, but rather voluntary. There's two different types of grading. First is quality grading, and then second is yield grading. Quality grades are associated with the palatability or the eating quality of the meat. Different factors that will influence the quality grade include the maturity or the age of the animal. Older animals tend to have more connective tissue, and with more connective tissue, the tougher the meat will be. The pH of the muscle decreases with age, as well as during rigor mortis when the glycogen breaks down to produce lactic acid. pH goes from neutral to about 5.5, which is the isoelectric point of beef protein. At the isoelectric point, the muscle fibers pull together, leading to water loss, which affects the perception of juiciness. The aging of the hanging beef or the beef carcass, beef is usually hung between 12 to 14 days, usually 1 day for every 100 pounds. This is done to increase the tenderness by letting the proteolytic enzymes act on the meat, kind of to break down those muscle tissues. During the hanging process, ultraviolet light is used to control the microbial growth. Humidity is set at about 70%, and the temperature is just above freezing. Most often you will see the grading of select, choice, or prime with your beef. Select is what is most commonly found in grocery stores, whereas choice and prime will be available at the retail stores and at restaurants. The final component of the quality grading of meat is the amount of marbling. And you can see here from the image, those flecks of fat throughout the muscle, that's our marbling. The higher quality meat, such as the USDA Prime, has much more marbling than that of the USDA Select. The second type of grading is the yield grading. And yield grades are based on the cutability, which indicates the proportionate amount of sellable retail cuts that can be obtained from a carcass. A yield grade of 1 to 5 is given, with 1 being the highest yield. There's different types of meat cuts. We have the primal cuts, also referred to as the wholesale cuts, and then the retail cuts. So we see there the primal or the wholesale cuts. That is where the carcass is divided into smaller sections. And then the retail cuts we get from the cuts within each of the different primals. Many times we are more familiar with the retail cuts, such as the rump roast or the sirloin steak or the ribeye steak. We're more familiar with those retail cuts because that's what we purchase. The primal are larger sections within the animal. And we can use, looking at the image there of the cow with the different primals listed, the chuck, the rib, the loin, the round, flank, short plate, shank, and brisket. We can look at that image and see that those cuts from, or those primals from the top of the animal, those are going to be more tender. Usually will be more tender because those muscles are less exercised. The cuts on the bottom that come from the bottom, those muscles are going to be more exercised, so therefore they're going to be tougher. They're going to give us tougher cuts of meat. So the amount of tenderness is going to impact how we cook that cut of meat. So knowing where the retail cuts of meat come from on the animal, that is going to give us some idea of how we might cook that cut of meat. There is a video in D2L on the different cuts of meat. I'd like for you to pause this presentation now, watch that video, get a better understanding of the different cuts of meats and where they come from, and then pick back up with this presentation. So as I mentioned on the last slide, the tenderness of the cut of meat is important in order to show us or to indicate to us how we should cook that cut of meat. So there's many factors that affect the tenderness of the meat and meat products. So we've already talked about the location of the cut. We also need to talk now about the age of the animal. Most often, the older the animal, the tougher the meat. This is really noticeable with poultry. So the older the chicken is, the less tender the meat is going to be. That is due in part to the amount of connective tissue. As the animal gets older, the amount of connective tissue increases. Also, the amount of fat will increase as the animal gets older. So the amount of fat, generally speaking, the more fat, the greater the perception of juiciness will be. But the types of fat will come into play here. Marbling, the intramuscular fat, behaves differently than the intermuscular fat. Lastly, we can utilize different preparation and cooking methods to impact the tenderness of the cut of meat. So we can do dry versus moist heat cookery, which we'll talk about in just a minute. We could use meat tenderizers, tenderizing agents, such as we have pictured up there on the upper right-hand corner. One tenderizing agent is papain, P-A-P-A-I-N, and that's what we're going to find in that McCormick meat tenderizer image. We can use marinades, which is the middle picture there. The acid in the marinade will help to hydrolyze some of that meat protein to make it more tender. Lastly, we can grind or pound the meat. So the bottom image there is of the meat hammer. So that will physically break up, cut some of those muscle fibers. One way to tenderize meat that comes from the bottom of the cow is actually to grind the meat. That is where we get our ground beef from. It's just simply a way to tenderize tougher cuts of meat. So the effects of heat on meat. So when we cook meat, several things will happen. The bacteria is destroyed. The meat is easier to chew. The flavor is enhanced. The protein will coagulate, leading to a shrinkage of the muscle fibers that will toughen the meat. So therefore, the longer you cook the meat, the more tough it is going to be. The fat will melt and soften, leading to a sense of juiciness and flavor. Water will evaporate. The bound water will be released from the muscle fibers, and then that water will evaporate, leading to the shrinkage of the muscle fiber. We will see those color changes within the myoglobin that we talked about earlier. And then the collagen will soften into gelatin, while the elastin will remain tough and fibrous. We can cook meat either through dry heat cookery methods or moist heat cookery methods. With the dry heat cookery, the heat is transferred to the food through air or fat. Dry heat methods bring about a shorter cooking time but use a higher temperature. Dry heat methods are best used for tender cuts of meat. Oftentimes these cuts are located near the center top of the animal, and they contain less connective tissue. An easy way to remember to use dry methods with tender cuts is the fact that the tender cuts are already tender, meaning that you do not need to add additional moisture to make them more tender, to make those cuts of meat more tender. So you can see there from the image the different types of dry heat cookery methods. On the other hand, with the moist heat cookery, heat is transferred to the food through a liquid. This cooking method uses lower temperatures and requires a longer cooking time. So think of stews or soups where you are simmering the soup on low for a longer period of time. Moist heat methods are therefore best used for the tougher cuts of meat. So these are the cuts from areas where the muscle has been exercised more and contains more connective tissue. So we need a little extra moisture to counter the toughness of those cuts of meat. So you can see there the different kinds of moist heat cookery: the stewing, the simmering, the poaching, steaming. All of these are where the food is cooked through some liquid. So that liquid could be like a chicken stock. It could be wine, which has the added effect of the pH on it as well. Steam, tomato juice, other juices, liquids, water. Now, a point of caution here. When buying meat and when buying marinades, I want you to be aware of the sodium that can be found in these different products. So if you look there at the Tyson label, nothing against Tyson, it was just the label that I could find online fairly quickly. If you look there, it says that there's portions of rib meat containing up to 15% chicken broth, salt, natural flavorings, and ice glazed. So right there it tells you that they have added salt to each of these chicken breasts. Okay, so an added source of sodium. Tyson is not the only company that does this. The next time you go to the supermarket, take some time and look for this, and you'll see that it's common among lots of different manufacturers. Then if you look in the bottom right-hand corner, there's a variety of different kinds of store-bought marinades or ready prepared marinades. Again, these provide an awesome flavor to different cuts of meats. Just want you to be mindful that many times they are a very good source of protein. So if you can make some of the marinades on your own, then you can better control the amount of sodium. The final topic for this chapter are the cooking losses. And cooking losses are the total losses, including the drip losses of the fat and the evaporative losses of the water coming out of the coagulated protein. AP weight, or the as purchased weight, is a little different than the edible portion weight. The trim weight is the weight of the part that you're not going to use, such as the bone or the skin. And then the as served weight is more of like the portion size, what you would have, the amount of meat that you would have to serve.